After meeting together in order to deliberate and decide, the committee has resolved to grant the BBVA Foundation Frontiers of Knowledge Award in Information and Communication Technologies category in its 14th edition to Professor Judea Pearl. In everyday lives, people constantly make decisions amidst uncertainty by considering outcome likelihoods and also by applying concepts of cause and effect. Prior to the work of Judea Pearl, such intuitive approaches were very difficult to encode in digital computer systems, limiting how well computer algorithms could sift through large amounts of real-world data and discern together whether two observations were consequential or simply coincident. By laying a mathematical foundation, first for concepts of probabilistic reasoning, and later for how to infer causal relationships through observed and ordered data, Pearl's work constructed a framework not only for computer-based thought, but indeed for entire fields of scientific study spanning computer science, mathematics, and statistics, epidemiology and health, and the social sciences. Pearl's work in probabilistic reasoning introduced the concept of a Bayesian network, a representation of events and their likelihood of occurrence. Such graphs enabled simple and graphical articulations of highly complex event networks and their probabilistic relationships, which enabled computers to solve real-world scenarios, discover latent dependencies, and predict outcomes through the propagation of probabilities. Bayesian networks have become intuitive, precise, and widely used tools for decision-making under uncertainty. Causal calculus, introduced by Pearl in his book Causality, provided a formal framework for reasoning about the assumptions under which causal relationships can be inferred from data. Practically speaking, this enables us to understand how to predict the effect of interventions and outcomes. By precisely characterizing confounding variables, the proposing methods for their derivation from data, Pearl developed a mathematical language for distinguishing between causal relations and spurious correlations. Beyond its broader impact across science and engineering, this formulation is playing a critical role in current research in fairness in machine learning algorithms. The breadth and depth of Pearl's interdisciplinary impact extends far beyond the fields of statistics and artificial intelligence. Not only did Pearl's mathematical and conceptual tools bring a modern foundation to artificial intelligence, they have completely changed the way uncertainty and causality are treated in the sciences, for example, in the development of fair and effective medical clinical trials. Other examples spanning psychology, robotics, and biology abound. Pearl's method are taught to nearly every undergraduate student in computer and data science today, and his own books have inspired sweeping advancements across our understanding of reasoning and thought.